Nuclear fallout is one of the most powerful and terrifying consequences of nuclear explosions, but it also reveals some fascinating science about radiation, weather, and the resilience of life. Did you know that nuclear fallout refers to radioactive particles lifted into the atmosphere after a nuclear explosion? These particles can fall back to Earth within minutes or drift for weeks across the globe. Fallout can travel thousands of kilometers, meaning a single detonation can impact areas far from ground zero. The size of the explosion and the altitude of detonation play a huge role in how much fallout is produced. Ground bursts create far more fallout than air bursts because they vaporize soil and debris into radioactive dust. Some of the most famous examples of widespread fallout came from Cold War nuclear tests at Bikini Atoll and the Nevada test site. These tests spread measurable radiation around the world, affecting countless lives. Scientists later discovered bomb carbon, carbon 14, from these tests, preserved in tree rings and even human DNA. This serves as a timestamp of humanity's nuclear age, a reminder of our past. Fallout contains dozens of radioactive isotopes, like iodine-131, cesium-137, and strontium-90. Each of these isotopes has different half-lives and biological effects on living organisms. For instance, iodine-131 decays quickly but can lead to thyroid cancer. Others, like cesium-137, can linger for decades in soil and food chains, posing long-term risks. Fallout patterns depend heavily on weather conditions. Wind, rain, and temperature can drastically change where radioactive material lands. Despite its deadly reputation, some areas affected by fallout, like Chernobyl and parts of Nevada, have surprisingly become thriving wildlife habitats after human evacuation. This paradox shows how adaptable nature can be, even in contaminated environments. Research on fallout has also helped scientists understand nuclear winter. This concept suggests that widespread fires and dust from multiple explosions could block sunlight, causing global cooling. Finally, fallout detection technology has led to global monitoring systems that ensure nuclear tests are detected anywhere on Earth. In essence, nuclear fallout is both a grim reminder of humanity's destructive power and a scientific lesson about our planet's fragile balance.